The total pressure of a mixture of oxygen and hydrogen is 1 atm. The mixture is ignited and water is removed. The remaining gas is pure hydrogen and exerts a pressure of 0.4 atm when measured at the same values of H and V as the original mixture. What was the composition of the original mixture in mole percent? So what they're saying is you have a mixture of oxygen and hydrogen, and when you heat it, when you ignite it, just get H2O. Let's first balance the equation here. Now it's a balanced equation. Now they're saying that the mixture is ignited and water is removed. Like let's say water is a liquid and it's not exerting any pressure. Fine. The remaining gas is pure hydrogen and exerts a pressure of 0.4 atm when measured at the same values of T and V. So let's say originally we were having X moles of oxygen and Y moles of hydrogen. Originally. Now when the combustion is over, oxygen is finished. Right, that is, we have consumed X moles of oxygen. For 1 mole of oxygen, we were using 2 moles of hydrogen. So for X moles of oxygen, we would be using 2X moles of hydrogen. So therefore, when oxygen becomes 0, hydrogen becomes Y minus 2X and it would form 2X moles of water which have been removed, which are not contributing to the pressure. So basically, initially, X plus Y moles were having a pressure of 1 atm. And now Y minus 2X moles are having a pressure of 0.4 atm. Also, since we have been told to calculate the mole percent of the mixture, so let's consider X plus Y to be 1. That is, initially we have 1 mole of gases of the entire mixture. So if X plus Y is equal to 1, X can be written as 1 minus Y. We'll plug this value into this equation. So Y minus 2 times 1 minus Y is equal to 0.4. Now why am I equating it? I'm equating it because if we apply the ideal gas equation, PV is equal to nRT, we can see that temperature and volume are said to be constant. It's only P and N which are varying. So P1 by N1 has to be equal to P2 by N2. Doing that stuff, we can directly say that they are proportional, right? So, let's go stepwise. So P1 is 1 divided by X plus Y, and X plus Y we've taken to be 1 is equal to P2. P2 is 0.4 divided by N2, which is Y minus 2X. So from here, we come here and we've substituted the value of X as 1 minus Y. So on solving this, we get 3Y minus 2 is equal to 0.4, or 3Y is equal to 2.4, Y is equal to 0.8. So if Y is 0.8, X would be 0.2. Now what had we considered to be X and what was Y? If you look here, X was the number of moles of oxygen and Y was the number of moles of hydrogen, correct? So the mole fraction in the original mixture for oxygen would be 0.2. Here it is for oxygen, and for hydrogen it will be 0.8. So your answer comes out to be option A.